So in this video we're going to talk about fractions on the SAT, and fractions are one of these things that we learn, we start learning these in elementary school. So to excuse the pun, but they're quite elementary. The problem is when we get into high school we kind of use them, but we use them as part of more complex things like algebra and geometry and trigonometry. So we sometimes we forget the ability to work with fractions in very basic ways, right? Adding or multiplying or figuring out what fractions are and really remembering what a fraction is and what it represents. And what sometimes makes this worse as well is that we rely too much on our calculators. As soon as we see fractions or decimals, we pop them into our calculator and don't think about it for very long. When instead, really, if we had a working knowledge with fractions, if we understood what they meant, we can always rely on that calculator, but at least we're going to have that intuitive knowledge of fractions that can help us not only figure out the answers to problems, but actually work through problems. So let's talk about fractions. Remember, the fraction's got two parts. Let's say we have a fraction x over y. We've got the numerator, which is the thing on top, and the denominator, which is the thing on the bottom. And the fraction is just an easy way of saying x parts out of a total y parts. So if we had a slice of pizza that was cut into 8 pieces, that is not a very good slice, so let's try that again. That's better. Right, we've got 1, 2, 3, 4, 5, 6, 7, 8 slices. If I asked you what fraction would be represented by these 3 slices, you would just say 3 chosen slices out of the total 8. So 3/8. This would be 3/8 of the pie or 3/8 of the circle or whatever, right? And that is essentially a fraction, right? It represents a fraction or a piece of a larger whole, and it's related to probability in some ways, which you can probably, if you've done probability, you can kind of see that you've got a fraction here, it's 3 out of 8, but we won't get into that. Remember, it's just a part of a whole. Another way to see it is the part over the whole. Now, how do we actually work with these fractions? Well, we can add fractions. Now, you could do this with your calculator, but I'm just going to make sure you remember how to do it by hand. When you add fractions, you can add them directly if their numerators if their denominators are the same. In that case, you just add the numerators. So this would be just 5 over 8, right? You add the top, keep the bottom. If we had something like 3/4 plus 6/4, that would just be 9 over 4. Now, if we've got a different denominator, say 3/8 plus, 3/4, we're not going to be able to add them directly because the denominators are different. So what you would have to do in this case is find the least common denominator, right? What is the number? What is the smallest number that these are both a factor of, essentially? So if we look at this, the shortcut, if you remember, was to just multiply them together and then convert each of these fractions into a fraction with that denominator. So 8 times 4 is 32, so we would convert each of these fractions into something over 32, but that's not the least common denominator in the case. The least common denominator is 8, right? Because if we multiplied this guy by 2 over 2, right, or 1, so we're allowed to do that, we would get 3 over 8 plus 6 over 8. There we go, right? This fraction is no different than 6 over 8. It's just written with a denominator of 8. This would make 9 over 8. Right? And we can also do this with subtraction as well. So if we have something like 5, 6 minus, 1/3, we would say, okay, what is the lowest common denominator for 6 and 3? Well, it looks like it'd be 18, right? Because 6 goes into 18 3 times, and 3 goes into 18 6 times. So we would just have to translate each one of these guys into a denominator of 18. So we'd have 18 here. And this would be, if we multiply the bottom by 3, we got to multiply the top by 3, so this would be 15 over 18 minus 6 over 18, right? If you do times 6 times 6. And we do that subtraction, we get 9 over 18. And another thing you can do is reduce, right? We can reduce this to 1/2. So once you've done your addition or your multiplication or your division, you can do simplification. So let's take another example of this. So simplifying, right? Something like, 20 over 50. Well, each of these, this is the same thing as 2 times 10 over 5 times 10. So we can get rid of the 10s, right? They cancel out. We're just left with 2/5. How about something a little more complex? 64 over 100. Well, this is just the same thing as 32 times 2 over 50 times 2. So I can get rid of these 2's. Well, this is just the same thing as 16 times 2 over 25 times 2. So I can get rid of these 2's. And is this anything? No, this is it. So 16 over 25 would be the final reduction. We can't reduce this any further. Right, and that's simplifying. Again, you could use your calculator for all this stuff, but sometimes it's actually quicker and more effective to be able to do it in your head, or at least do it out on paper. Another thing we can do is the difference between mixed numbers and an improper fraction. So a mixed number is just going to be a number like 2 and 1/3, where you've got your big number over here and you've got your fraction that's left over that doesn't kind of fit into that big number. Or something like 6 and 3/5. An improper fraction would be some fraction where the numerator is bigger, so x over y, where x is greater than y, where the numerator is bigger than the denominator. And it's important to be able to convert between these two, at least for the grid-in section. So how do we go from 2 and 1/3 to an improper fraction? Well, the method was you take this, you multiply it by this guy, and then you add the numerator. So this would be 3 times 2 is 6, plus 1 is 7, and then you just put it over the original denominator, 7/3. How about this guy? 5 times 6 is 30, 5 times 6 is 30, 30 plus 3 is 33. This would be 33 over 5. Now how do we go the other direction? How do we go from an improper fraction to a mixed number? Well, in that case, we just divide 5 into 33. So 5 into 33. That goes in 6 times, and then we just subtract this off. I'm just doing long division by hand. We're left with 3. 5 can't go into 3, so this is a remainder of 3, and we'll talk about remainders in a later boot camp. And what we do then is we just say, okay, this is going to be 6, the remainder 3 over the original divisor, so 3 divided by 5. And there you go. There's your mixed number, or excuse me, your mixed number recovered. So you just put your remainder over what you're dividing by, and that gives you your mixed number. Let's see. Final thing, a little tiny hint that might help you is, what do you do if you've got fractions in fractions? So what if you've got something like 1/2 divided by 3/4? How do you manage something like this? Well, actually, that's not a great example. Let me give it a little bit better one. 3/4 divided by 2/4. Okay. There's a number of ways we can approach this. First, we can kind of take this line here as, that didn't work out well, as the main dividing line. And look at what's on top and look on what's bottom. If we see something on the top that's equal to something on the bottom, we can cancel. Well, let's take a look at this over 4, right? Or this over 4. We can get rid of these over 4s because we've got an over 4 on the top and an over 4 on the bottom. Another way to see this is to see that this top is the same thing as 3 times 1/4, right? Or, and this is just 2 times 1/4, and then what do you know? We can cancel those and we're left with 3/2. Another way you can see this is, if you remember the rules for dividing fractions, when you divide a fraction you can just flip it and multiply. So this is going to be the same thing as 3/4 times 4 over 2. And actually this segues nicely into multiplying and dividing fractions, which we didn't really discuss. So multiplying and dividing fractions. So in this case, when we're multiplying and dividing fractions, we don't care about the numerator or the denominator. They don't have to be the same or anything like that. For multiplying, we just multiply across. So this would be 12 over 8, which we reduce to 3/2. When we divide, if we do, say, 3 divided by 4 divided by, I don't know, 7/8, we can't really do this by hand. What we have to do is, as I said earlier, flip this and multiply. So this is going to be the same thing as 3/4 times 8 over 7. And I'm going to do a little simplifying, make that 2. I'm going to get 6 over 7 as my answer. And that's multiplying and dividing. So you should be able to do that in your head. Especially if I ask you, well, what about 6 times 2/3? What would you do with that? You could put it into your calculator, or, well, if you do that, you're going to get a nasty decimal. Or what you can do is just multiply across. Imagine that this is, over 1, and then just multiply across like you normally would. So 6 times 2 is 12, 1 times 3 is 3, and then this would just be reduced to 4. And that is essentially what you need to know for fractions and for decimals. Now going back to this, actually for fractions, sorry. Now going back to this briefly, what if we had something like, I'm running out of room, A over B over C over A? What would we do in this scenario? Well, again, take this line and separate your fractions, right? Here's one fraction, here's another. So this is our main dividing line. Now, we have an A here, but we have an A here. Can we cancel them? Well, no, because this A is on top of this fraction, and this A is on bottom, so we can't cancel. What we can do is, let's just take this fraction right here, flip it, and multiply. So this is the same thing as A over B times A over C, which is just going to be A squared over B C. So we really couldn't have done any reducing or simplifying there. And that is it for fractions. So there's a lot here, and I know you can do a lot of it with your calculator, but understanding what a fraction is and how you can use it, how you can work with it on paper is so key, not only to get answers right, but also to understand how the SAT wants you to approach certain questions.